Okay, cool. Okay, let me just quickly see if I can. Okay, so let's start study unit 10. I just want to get back to. Okay, and we're doing the chi-square test today. So basically, the work that we have done in the lead up to this would have been your binomial, your Poisson, and then a lot around the normal distribution. And within that normal distribution, where the normal distribution with a known standard deviation, we would have used the Z. Unknown standard deviation, we would have used the T. Then if we look at the proportions, we would have used Z there as well. And basically from there, we went into the confidence intervals around that, and then we went into the hypothesis testing. So now we're moving nearly away from the Z values, and we're going into a chi-square test. And what the chi-square test does differently than your normal distributions, it is basically looking at two variables, and it is asking then a few questions around those two variables. So it will basically ask if the variables are independent or if the variables are not independent. And I think that is the one thing out of this that you can nearly remember is when you get to the questions that they ask around study unit 10. When we looked at the other hypothesis testing, we said, okay, we look at the not equal, the bigger, the smaller. When we look at chi-square, it is always going to be the null hypothesis that will test independence, and then the alternative hypothesis that will test dependence. So I think this is always the important one. The H0 test independence, where the alternative will then say dependent. Okay, so whenever we look at the question sets, this is how you need to look at when we ask around H null and the first hypothesis. Okay, so let's then just look at the next step. So in this hypothesis testing and things that we will do, I think the next thing that is important is that we look at what other steps there are. So firstly, we'll do the null hypothesis and the alternative. So let's get okay. So the first one is the null hypothesis, alternative hypothesis that we look at. So that's your first step. Your second step that we going to look at is your degrees of freedom. So in your t-test, when we looked at degrees of freedom, we only looked at n. When we now add chi-square, we will have a different way of working out the degrees of freedom. So in the chi-square, the degrees of freedom, the one way of doing it, or the one is to look at the number of rows in your table. The other one is the number of columns. So the number of rows minus 1 is for 1 times the number of columns minus 1 gives us the degrees of freedom. What is also important to note with the rows and columns, it basically says how many variables we have in the columns and how many variables we have in the rows. We're not including total, so total is not included, and on the bottom as well, total is not included. But I'll show you now in a few examples how we're going to do that. So first, null hypothesis, alternative hypothesis. The second one that we look at then is to say, look at the degrees of freedom. Then, as with your Z and T and all of those things that we did, here we will also have a level of significance. So basically, very similar to those problems, we will also have a level of significance in this question set. What we will also have is a test statistic that we will work against. And then basically also what we will do then is to say that we make a decision around that. Okay, so your critical value that I now see wasn't mentioned somewhere in here. Your critical value we will also work out with a table. So that is the one that still needs to be included in here, is that there's also a critical value. So basically very much the same as we did in the previous chapter about hypothesis testing. We're going to do nearly the same process in the chi-square. So the first step is to look at the different hypotheses. The second step is to look at the degrees of freedom. Fourth step is to look at your level of significance. With that level of significance, we're going to work out a critical value. Then, if we need to work out the test statistic, which is quite long if it's a big table, and then we need to make a decision. So that's roughly the 5 or 6 things that they can ask us in our chi-square analysis. So let's go to the first one. So the first question that I have here is only looking for us to ask the degrees of freedom. Okay, so this question asks us to work out the degrees of freedom. So degrees of freedom is the number of rows minus 1, the number of columns minus 1. So in this, they tell us in a contingency table has 4 rows. So they tell us it has 4 rows and 5 columns. They tell us 5 columns. how many degrees of freedom. Okay, so this one is I think this one is too easy to be in your exams as a question just like this. So we'll get to the question sets a bit later on. I think how it will be more not appropriate, but how it will look in your exam. So 4 minus 1 is 3. 5 minus 1 is 4. So your degrees of freedom for this one would have been 3 times 4, which gives us 12. Okay, so let's say, for example, they told us alpha was 0.05. I just want to show you some bit more. So with degrees of freedom of 12, alpha 0.05, what will the critical value be? Okay, so obviously this wasn't asked, but I want to show you just how we get to that as well. So let me see, where is that on the table? So in chapter 10, and probably towards the end of chapter 10, we will have the chi-squared table. I'm just quickly looking for it so that I can share it. I hope it is there. Yes, okay. So we're looking at the alpha that is 0.5 or 0.5. So 0.05 is there. Set at 12. So your critical value for that sum would have been 21.026. Okay, so if we needed to work it out, the critical value is 21.026. Okay, but we'll do a few more of that. I just wanted to show a bit extra how we get to the critical value. Okay, so let's go to the next question. Okay, question 2. So in question 2, we've got the table. They ask us in the table, you will see that they ask us, or in the set of questions, they talk about the null hypothesis, they talk about the alternative hypothesis. They don't ask us or give us anything around the degrees of freedom. Then critical value, sometimes they can throw in an expected value and then the calculated test statistic. So I just want to roll through a few of these. So again, the null hypothesis, alternative, degrees of freedom, critical. So basically in your chi-squared testing, you will see that is nearly coming up this every time. They'll throw in one of the hypotheses, there's the degrees of freedom, there's the t-stat that they calculated, observed, expected. So yeah, so nearly that is the things that we need to remember. And please, again, you can keep this printed. So H0, as I said from the start, it's always independence. Null hypothesis is the two variables are independent, correct. So if that is independent, the other one must be dependent. That is also nearly a way to test in your options that they give you. So if I say incorrect and they give you both hypotheses, then very seldom they can tell you The null hypothesis is dependent. The alternative hypothesis is independent, because then both will be wrong. So it is nearly, or they give you both and you know both is right, or they can give you only one of them. Okay, so I just want to show you that as well, because nearly if a one is independent, the other one needs to be dependent. Null hypothesis is always the independent one. Okay, so we know those two are correct. Critical value, we can work that out now. So they didn't ask us in the question degrees of freedom, but now for the critical value, we need to work out the degrees of freedom. So let's quickly work out the degrees of freedom. So how many variables in the rows? So there's yes or no, so it's only 2, so 2 minus 1. In the columns, it's A or B, so again 2, so 2 minus 1. So the degrees of freedom is 2 minus 1 is 1, 2 minus 1 is 1, so it's 1 times 1, which gives us 1. So when we look at the table, we will look at the table where it is degrees of freedom is equal to 1, and we have a 5% level of significance. Okay, and 5% is 0.05. Okay, so let's look at that table. Degrees of freedom is 1, 0.05. So 3.841, 3.841, which is correct. Okay, so we're still looking for the incorrect one, but that is how we would have looked for the critical value. So just again, how we look for the critical value is where we have a degrees of freedom that is equal to 1, and the level of significance which they give us is equal to 0.05. So we go to the table, degrees of freedom 1, 0.05, and that value where those two crosses is 3.841. Okay, so critical value ticked. Okay, so the expected frequency. So do any of you know how to work out the expected frequency? If not, it's fine. I'll show you. Okay. So the expected frequency, I also jotted it down here how one calculates it. So this is how you calculate the expected frequency. So let's look at the expected frequency for yes and B. Okay, so expected frequency for yes and B. Okay, so that value of 25, that is not expected, that is your observed. So in the values that they give us, that is the observed value. So we still need to find out if the expected value is also 25. So how we work it out is that we say the total of yes, so it is 65, times the total of B, which is 70, divided by the total of your big sample, which is 145. So that will be our expected value. Okay, so that is if it was distributed nicely within the table, that is what we would have expected the number to be. So 765 times 70 divided by 145 gives us 31.38. So that is what we expected it to be. What was observed was 25. So obviously there's a difference, but the expected frequency should have been the 31.38. So because that one is wrong, we assume now that option 5 is correct. But let's quickly do that. But I'm going to use Excel again so that you guys can then, when I share it, you can use it for other calculations as well when you can change it. I think let's do that, when at least we have a spreadsheet that you can use for later on as well. Okay, so let's just, I'll put it onto the screen now that you can also just see what I am doing. Okay, so that is basically the 75, the 70 that we have there. And where you have the 65 and the 80. So that is all your observed data. So let's just put in an expected. So we would have expected the values to be that times that divided by that. That would have been our expected okay, we'll change that now. Okay, so that would have been our 4 expected. So now that we have that, we needed to work out the chi-square. Okay, so I think there is a chi-square function. Let's see. Okay, let's see which one will it be. Okay, that was your actual range. That was your expected range. Let's just check if that is correct and if that is how the function is. dependence. Okay. So let's just get the other one as well, because I think that is your into left-tailed. That is quite interesting. Dependence, a value for a chi-square distribution is the degrees of freedom. Okay, I'm not looking for the probabilities. Okay, so that will, okay, let me use the formula. I think that one is wrong. So the formula is so let's just get that from the, so your test statistic that we're going to work out, it is the sum of your observed minus expected divided by the expected. So observed minus expected divided by expected, and that is then the square root of that, or the square, not the square root, the square of that. And then the rest of the formula then basically say for all four of those we need to add it. So I will just quickly check. So it's that one minus that divided by that, that one minus that divided by that, the same. Okay, so let's quickly check what the answer was and if that is, okay, see, this is interesting. So they're not telling us, so when I calculated it was definitely a different answer. Did I use the correct values? Yes, I did. Okay, so with option 5, they're actually not working with those numbers. They just tell you. So they tell you that, so we've looked at the critical value of 3.841. That is what we worked out. So suppose that the t-stat is sitting there, what do you do? So like we have seen in hypothesis testing as well with your normal distribution, to that side, what do we do if your t-stat is lying to that side of your critical value? We will reject. If it lies to this side, we will accept it. So this actually, they have not worked out like I now tried to get to that answer. They just said, okay, but let's assume that is the number. What would your assumption have been? So, but I'm going to keep that Excel that for the next one we might use it, and I will definitely send it on with this one. So basically in this question you didn't need to work out the test statistic. You could have used what they told you to use, and then you could have made the assumption of reject or accept. Okay, before we go on to the next one, does this make sense, the flow of a chi-square and the process that we need to follow? Because that will be nearly the flow for all of them, is to look at that 5 steps and to just nearly tick all of them every time. Okay, so let's look again. Incorrect one. So is H0 dependent or independent? So we know H0 is independent. If H0 is independent, the alternative is dependent. Then the next question is we need to look at the degrees of freedom. So in a test for the independence of two variables, one of the variables has 2 possible categories. Okay, so it has 2 possible categories, and the other has 3 possible categories. Okay, so if we need to do the degrees of freedom, we would have said 2 minus 1, 3 minus 1, 2 minus 1 is 1, 3 minus 1 is 2. So the degrees of freedom would have been 2 and not 6. So that would have been the wrong one. But let's still look at critical value. So we've got the degrees of freedom. They tell us at 5% level. So we've got the level of significance is 0.05. So let's go to that table, 2 and 0.05. 2 and 0.05, which is 5.991. 5.991 out of the table. So critical value is correct. So they set in the up there. So we look at the critical value is 0.4. Critical value 5.991. So that is from what we have calculated. They tell us that your t-stat is somewhere here as 3.456. Okay, so as in previous one, what do we do here? Okay, so if it was lying on this side, we would have said we reject it. If it is lying to this side, we would have said we accept it. So we would have accepted. Okay, so let's see. Okay, so now again, what we see is fail to reject. So instead of just saying we accept it, so fail to reject is the same as accept. They could have just say we accept H0. So we fail to reject, so we can't basically reject it. So if you can't reject it, you accept it. Okay, so the words that nearly you can see with all the hypothesis testing, even the previous chapter, chapter 9. So words for accept H0 can be fail to reject H0. They can say, fail to reject H0. They can even say that you reject the alternative. So again, just nearly look at the different wordings that can be used to say exactly the same thing. Okay, so fail to reject and accept is exactly the same. So in this instance, we accept null hypothesis. So in actual fact, we fail to reject the null hypothesis. Okay, so let's do another one like this and nearly just get you into this, the motion, how we do this every time. So the first thing that we look at is your two hypotheses. So remember, okay, so here we're looking for the correct one. Is H0 independent or dependency that we test? Okay, so H0 is always independent. So in this instance, the first one is incorrect, but we're looking for a correct answer. The observed frequency for acceptable and employee John. Okay, so we need to work out what is that value. Okay, how would you work out what that value is? Okay, so to get to that value, we basically need to say 950, which is your total, minus Peter. So that would be your value for John. Okay, and that value is 685. Okay, so 950 minus 265 give you the 685. So also wrong, but we're still looking for the correct answer. Okay, so that is observed. So let's just quickly see. So if that is 685, if that is 1000, that is 950, that value should be 50. If that is 685, this is 700, this value is 15. If that is 1000, that is 700. Employee Peter is 300. And if that is 300 and that is 365, unacceptable will be 35. And then you can see 35 plus 15 equals 50 again. So let's just see the expected frequency of acceptable and employee Peter. Okay, so again, how do you work the expected out? So we would have expected it that it is 950 times Peter. Nearly made a mistake. Peter is 300, and that answer divided by the total of 1000 will give us our expected frequency. So 950 times 300 divided by 1000 gives us 285. Okay, so the expected frequency is not 265, it is 285. Degrees of freedom. Okay, so we have accepted and unaccepted. So we've got 2 minus 1. Peter and John, so that's 2 minus 1. So 2 minus 1 and 2 minus 1 is 1 times 1. 1 times 1 is 1. So our degrees of freedom is equal to 1, and that is a correct one. But let's just look at the next one. So suppose the calculated t-stat is this. Okay, so let's just draw that again. Let's just draw that. So let's first work out the critical value. Okay, the critical value we can work out because we have the degrees of freedom. 1, they tell us what the level of significance is. It is 5%, so it's 0.005. So once again, table degrees of freedom 1, 0.05, so we sit with 3.841. So a critical value 3.841. So if the value, the t-stat that you calculate is sitting to this side, what happens if it's sitting to this side? What happens? So sitting to this side, we accept H0. Sitting to this side, we reject H0. Okay, so 40 is definitely way much bigger, so we reject H0. Remember, we're looking for the correct one. So H is not rejected is wrong because we actually rejected. So that one is also wrong. Okay, so just again to show you how we would have worked out, given a critical value that they actually do give us because they give us 1% of freedom and the level of significance, we can work out with the test statistic that they give us if we reject or not reject. Okay, so again, we followed the process nearly from, we looked at a hypothesis that they gave us, observed and expected, which was now nearly new in this one, but they gave us both. Then they give us a degrees of freedom. They didn't ask us anything about a critical value, but they still ask us to reject or not reject the statement that we made. Okay, so again, if you look at that 5 steps, nearly each of that 5 steps is covered in this question. Okay, questions up until this point? Okay, otherwise we just continue. So no worries. Does it make sense? Are you feeling a bit more comfortable when you're going to start with assignment 5? So it will only be live tomorrow, but hopefully this will make sense when you start looking at assignment 5. Okay, so let's let's look at the next question. So what I've done here is basically to say, and what I will do is I will just bring in my spreadsheet here as well. So this is quite interesting. Okay, a sample of 500 shoppers was selected in a large metropolitan area to determine various information concerning consumer behavior. Mama questions asked, do you enjoy shopping for clothing? And this was the results. Okay, so let's see if I so if I change that, so let's just move this. Why doesn't it want to move now? Don't worry. Come on. Okay, so let's just see. Okay, so there is the 9.51. There is the 25.49. There is the 12.49, and there is the 53.51. So one can then use this to calculate that. The t-stat that we want to work out. So this is just still a problem. I just want to check something. Because this is then where the problem still is. So I just want to make 100% sure then that we're using the right formula. So it's observed minus expected divided by expected observed minus expected divided by expected, and we basically do that. And if I sum all of those, it must give me observed minus expected divided by expected. That is fine. Okay, so obviously there's something wrong here. I'll just see what I'm missing in this formula, because that now doesn't make sense. I just want to check if that formula is not doing something strange. So I want you guys to be able to use this formula sheet. Yeah, see, so no.
Hi, Jean.
Yes.
Can you maybe check for me? The document you're working on now differs from the document you sent on the group.
Yes. I'll update. I added I
Okay.
added like 2 or 3 questions extra in which I thought we must also look at. So I'll update and send this again to you. Don't
Okay.
worry.
Thank you.
So I just want to see where my calculation is wrong. So let's just bring that in again. So it is It is 12 minus that divided to the power of 2. But then I get different answers. 12 minus. I just want to see if there is something in my. There's definitely. So the process is being done correctly. So that gives me the same answer. Is that formula correct? That formula is correct. Okay, I will just need to look at what. And let me just check on the calculator as well. If there's something in my Excel that is wrong. See, so with a calculator, I also get this. Okay, I'll see all of them. That minus that divided by that to the power of 2. And all of them have different numbers. Okay, I will need to go and check because this feels. Hopefully it is in the calculation, but not. Okay, I'm wasting time now, but this is not right if. because all of these I get different numbers. Let me just get the original. I see that is also. Okay, I'll need to go and check this from the textbook. Let me just, while we are on this, I'll just go to the textbook and just see what the formula is, and if a formula has been written wrong, else okay, so this is wrong, and that is from your study guide. Oh. Okay, so the right formula is so that's why the other one also didn't work out. Okay, at least. So if the right formula, so I think it is in your study guide, it is correct, but not in the extra workbook that you got. So it is observed minus expected, the square over to the power divided by expected and the sum of that. Okay, so let's just okay, so where did they again, that formula is wrong. So everywhere that they showed it, it is wrong. It must be that's why if you're going to work that out, it is not going to be the same as that, but this is correct. Okay, so that is correct and that is correct. So now we can work with this, which I will also share with you. To work out the chi-square. So definitely, I'll just check in your study guide as well for study unit 10, what is the formula, but the one in your extra extra questions, definitely it is wrong. Okay, so that's why it never worked, but now at least we have that right, and we will then be able to use the spreadsheet. Okay, so there's everybody that just watching this later on, in your extra guide that has all your exam, there is a mistake in study unit 10 on how to calculate the test statistic. And that formula is also, if you have the book, the study book, it is on page 307, but I will also just make note of it and send it in the group as well. Okay, so that's why that other one was also, we couldn't get it correct because of a formula. Okay, so at least, so that is wrong, that calculation, but the next step of the actual answers is correct. Okay, so the last one, and again, let's try to cover all of the options here. So even if I don't ask us, the first thing that we will look at is H0. So H0 is always independent. The alternative for chi-square is always dependent. Okay, so that is the first step. Then second step, so again, not going to follow that now. The second step, degrees of freedom. And the reason why I nearly do these steps first, because that's the easiest ones that I can nearly think of. So degrees of freedom, how many rows? 1, 2, 3. So the formula is 3 minus 1. How many columns? 3. So 3 minus 1 is 2. 3 minus 1 is 2. So 2 times 2 gives me 4. Okay, so then the third step is, do they tell us level of confidence? Okay, here at the bottom, level of significance they tell us about. So let's just work out critical value. Critical value we can work out with a 0,05 and degrees of freedom of 4. So let's go to the table again. Let me get the table. So degrees of freedom was 4, 0,05. So where those two cross, we get the critical value of 9,488. So critical value 9,488. Okay, so then let's look at, okay, so their critical value 9,488, correct. Degrees of freedom, correct. Okay, we haven't looked at observed and expected yet, so let's quickly add that into the mix. Okay, so observed is the easier one because observed is as is from the table. So let's just do another color. So observed frequency of buyers under the age of 30. So under the age of 30. And bought large car, so small, medium, large car. So where those two cross, that is your observed value. So your observed value is 34, which was also correct. Okay, so let's work out an expected value. So expected value of buyers above 45 and bought a medium car. Okay, so how we worked out expected value is the total of the above 45 times the total of the median, that was the 99, divided by the total, which is 300. So in normal circumstances, we expected that that would be your expected value. So it is 120 times 99 divided by 300, which gives us 59.6. Okay, which is correct. Okay, so the one that's incorrect is that one, but let's see why. So suppose for t-stat, okay, let's do this drawing. Imagine that is a chi-square. So we set the critical value that we calculated is 9.488. So if that was the critical value, if a t-stat is lying to that side, we say reject. I think that is nearly how we can do this process every time as well. If it's lying to this side, we say we accept the null hypothesis. Okay, so they say t-stat is 18. So 18 is going to be somewhere in this. So we will reject the null hypothesis. They say we cannot reject, so that is where the mistake is, because we will reject it. Okay, I just want to check now in the study guide if at least the study guide is correct with that formula, which I think it is. I see, so the study guide is correct. Okay. So at least the study guide is correct, not the So if you go to the extra exam questions, you will see that the formula on page 210, that formula is wrong. Okay, so this formula is wrong on page 210. Okay, so that is where the mistake came in. That formula is wrong. And then I assume in most of the calculations that they show in that chapter, the first part of it, they will probably also have issues with how they show how you calculate it. Okay, so it's not there, it's not there. So that was the one that we looked at, so that was definitely wrong. The question 10, how they showed that. So there's basically one that they showed how to calculate it. So one can very easily have made that mistake with the formula that they have given us in that extra study unit. Okay, but at least now I've corrected it in my Excel that I will also share with you. And then that is your is that you can work with that. Okay, questions on study unit 10. So I know you guys will only start being able to look at it from tomorrow, but at least when we can do study unit 11 next week, and when we can do one or two more sessions maybe on those two study units, and then look in depth into some of the other study units before we actually know when you are writing exams. Okay, anything else from your side, guys? Happy with this thus far? We will definitely relook study. Let me just stop the recording.